All right, good morning. So continue on with trig expressions. Today we are going to simplify trig expressions. All right, so we're going to rewrite it as a numerical expression or in terms of a single trigonometric function. Got to use our identities to help simplify these. So hopefully you have that reference sheet, because as I was going through the notes and creating the answer keys, I had to look at that all the time. Okay, the big one that's used is your Pythagorean identities. All right, so make sure you have that handy. At my house, I have it hung up on my wall, as corny as maybe as a math teacher, but I'm here working for you guys, so just have that handy so you can reference it. All right, it's a lot of plug and play and using those identities to get what you want. All right, so some strategies. We're going to rewrite using a reciprocal and quotient identities. Look for Pythagorean identities, as I just said. We're going to combine fractions using common denominators, break fractions apart, and use everyone's favorite factoring. All right, so for example 1, we're going to simplify secant theta minus sine theta times tangent theta. All right, so the first thing is secant is the reciprocal of cosine. So I'm going to start off right there. So minus sine theta over 1, and then tangent is sine of theta over cosine of theta. Sorry about that. All right, so from here, I'm going to multiply those two together. This gives me minus sine squared of theta over cosine of theta. Now, since we have common denominators, I'm just going to combine my fraction. So 1 minus sine squared of theta over cosine of theta. All right, so I'm going to use a Pythagorean identity here. All right, on the top, which is sine squared of theta plus cosine squared of theta is equal to 1. So if I minus sine squared of theta, I'm going to get cosine squared of theta is equal to 1 minus sine squared of theta, which so happens to be right there. So next, I'm going to replace 1 minus sine squared of theta with cosine squared of theta over cosine of theta. Nice thing is, cosine cancels out. One of them on the top and the bottom one completely. So you get left with cosine of theta. That is how we're simplified, ladies and gentlemen. All right, you just get better at it the more you do. I think there are a lot of examples. There's 12 of them, so I'm gonna do 2 parts: the first 6 and then the second 6. So to simplify the expression, we have sine of theta plus cosine times tangent. So sine of theta plus cosine of theta over 1 times tangent, which is sine theta over cosine theta. Nice thing here, boom, cancels out. Cosines go away, so then I'm left with sine of theta plus sine of theta. Combine them, it's like x plus x, all right, would be 2x, so sine theta plus sine theta is 2 sine theta. And that's it. All right, obviously we're going to get harder as we go through. So now we have cotangent squared of theta minus cosecant squared of theta. So we're looking for our quotient identities or reciprocal identities, Pythagorean identities. All right, so first I'm going to start with what cotangent is. Cotangent is really cosine squared of theta over sine squared of theta. Minus cosequant is the reciprocal of sine. So 1 over sine squared of theta. Now we have common denominators, so we'll just combine combine terms on the top. So cosine squared minus 1, all divided by sine squared theta. Again, this looks kind of familiar. That's cosine squared minus 1. So it's my Pythagorean identity of cosine squared of theta plus sine squared of theta equals 1. Now to get this, I have to do a couple steps. So first, I'm going to minus cosine squared of theta. So I get sine squared theta equals 1 minus cosine squared of theta. Now I'm close to what I want, but I need a negative 1. So I'm going to flip the on the right. Watch. So I'm going to get negative cosine squared theta plus 1. Now I need to change that plus 1 into a minus 1. So let me divide everything by negative 1. So I get negative sine squared of theta is equal to positive cosine squared theta minus 1. Now I have what I need on top. So this will go back to there. I get negative sine squared of theta over sine squared of theta. Okay, the signs cancel out. You get negative 1. I know, mind blown. Example 4. All right, so the things I look for when I'm going through these, right? So sine, cosine's good, leave them there. I'm looking for these tangents and these cotangents. So I'm like, all right, how can I rewrite these? What can I do? Okay. How can I pull things apart? So first thing I notice is sine over cosine is tangent. So it's really tangent of theta times tangent of theta plus cotangent of theta. Okay, so if I FOIL this out, I get tangent squared of theta plus tangent theta cotangent theta. Now this really looks like this over here. So tangent is sine theta over cosine theta. Cotangent is cosine theta over sine theta. And we see that everything cancels out, so we get just 1. So tangent times cotangent is 1. Tangent squared of theta plus 1. Okay, so let's see. Let's go to our Pythagorean identities. If I look at my Pythagorean identities, okay, I see that tangent squared of theta plus 1 is really secant squared of theta. Boom. So final answer over here is secant squared of theta. Alright, gotta have these, like as I'm doing this right now, I have an answer key in front of me and I'm still looking at my reference sheet. Okay, example 5. You have cosecant of theta minus cotangent squared theta divided by cosecant. So let's see if we can make common denominators and add them together. So over 1, which means I need to multiply top and bottom by cosecant. So it gives me cosecant squared of theta minus cotangent squared of theta, all divided by cosecant of theta. That's ugly. Alright, so looking at this, I'm looking at my reference sheet, looking for cotangent or cosecant. I see I have one that has both of them. So my identity is cotangent squared of theta plus 1 is equal to cosecant squared of theta. So if I subtract cotangent, I get 1 equals cosecant squared of theta minus cotangent squared of theta. And that is what we want. So I'm going to substitute 1 over cosecant of theta. And cosecant is the reciprocal of sine. So flip it over and we get sine of theta. Example 6. Cosecant of theta minus sine of theta over cosecant of theta. Alright, so I'm going to pull this apart. So I have cosecant of theta over cosecant of theta minus sine of theta over cosecant of theta. Cosecant over secant, cosecant is 1 minus sine of theta. Remember, cosecant is the reciprocal of sine, so I'm going to flip that over and I get sine of theta. So I get 1 minus sine squared theta, because that's multiplication. Alright, I'm going to go look at my identities again. I know that cosine squared of theta plus sine squared of theta is equal to 1. I'm going to subtract sine squared of theta. So, just by doing them enough, you start to remember how the identities are rewritten. So cosine squared of theta is 1 minus sine squared of theta. So my final answer is cosine squared theta. Okay.